Welcome to my presentation. In this presentation, let us look at the distribution rule and how we can apply it to some of these algebraic expressions. So let us see what a distribution rule is. Let me explain this. If we have three terms like this, a, b, and c, and if a, b, and c are real numbers, then we can write the distribution rule as follows. If these three numbers are connected in a way which is shown here, a times b plus c within parentheses like that, the distribution rule is telling us that the term which is outside of the parentheses will be multiplied to every one of the terms inside the parentheses. Or we can also state it as the term which is outside of the parentheses will be distributed to every one of the terms inside the parentheses, and therefore we can write this one as follows: a times b plus a times c. So a times b we can write it as ab, and then a times c we can write it as ac, and this is what is called the distribution rule, or sometimes also called the distribution property. We will use this distribution rule to try to understand some simple examples. Okay, so let us look at an example here. Let's say we have an example where we want to simplify 3 times 2a plus 7. We're just taking some simple examples so that way we should be able to understand the concept, apply the concept, and then be able to arrive at an answer. So in here we will break it down into these different steps, so that way we will have a logical path to the solution. So what do we need to do? This is what was given to us: 3 times 2a plus 7. According to our distribution rule, we're going to take the term which is outside of the parentheses and then distribute it to every one of the terms inside the parentheses. And when we do that, this is what is going to come out of this: 3 times 2a plus 3 times 7. That is what we have. So therefore, when we simplify this, 3 times 2 is 6a plus 3 times 7 is 21. Since these are different terms, we cannot combine them, and therefore we're going to leave it here, and then we can call this as step 2. Okay, so this is the way we can simplify some of these algebraic expressions. Let's take another example. In this example, let's say we want to simplify -5 times 4a plus 6. Simple example. So what do we need to do? We'll write it down in these different steps. -5 times 4a plus 6. We have the -5, the term -5 which is outside of the parentheses. We're going to take that and then distribute it to every one of the terms inside the parentheses. And how do we do that? We'll write that as step 2 and simplify the process. -5 times 4a and then plus -5 times +6. So that is what we have. And therefore, when we simplify this is how it's going to simplify. We know that a negative quantity times a positive quantity will always be a negative quantity. So therefore, negative times a positive is a negative. 5 times 4 is 20, and we have the variable a. We'll write the variable a next to it. Then positive times negative, positive times a negative is a negative. So therefore, we'll put a negative sign there. And then 5 times 6, which is equal to 30. So therefore, that is where we want to leave it. These are two different terms. Therefore they are non-similar terms or unlike terms, and therefore we're going to leave it here, and that is going to be our answer. And in my next presentation, we shall look at some more examples as to how to use these distribution property to be able to solve some more variable expressions